Sorry for the interruptions. My laptop's power off. Okay, anyway, we can continue. Okay, so I wanted to answer one of the questions has been arised. Okay, so yeah, somebody has asked midpoint and the sense of initial guess same or something. Okay, so it means the things what I have derived now as a method. Okay, that is the general one. So you may want to know what is that C1 is equal to C naught minus f of C naught over f dash C naught. Am I right? So this is our steps, no? Let me check it. Yeah. Okay. So in the Newton-Raphson method, we have one the steps. We have this one. So we need to know how they have got it. So if you know the way how they get it, so it is easy if you even if you forget this one, you can derive it. No, so every time you don't need to derive, you can use the steps what we have studied in last class. Okay, but what I have did today too, for you to understand how this comes. Okay, so hope you understand that. So in when you're doing the questions, okay, in the questions you don't need to derive that. No need to derive. Okay, but when you are studying, you study that. It will help you to memorize this way how they have gone. Even if you forget whether f dash come upper and f come down, so you may confuse in the exam or somewhere. So you don't need to confuse. You know the way how to derive it, so you can derive it. No? So that's what I wanted to teach that one. Okay. So that's the purpose I gave you. So you can use for that purpose, but use the steps what I told you in the last class to do the questions. So understand? Is that clear the questions somebody asked? Did you all understand what I mean? Please let me know. Or do you have any confusion still? There is the answers. So when you're doing the questions, okay, you have to follow the steps what I have done in the last class, lecture number 3, okay, where we have studied how to solve it. But in this class, I wanted to show you how they have derived this part, okay. So, this won't confuse you when you forget also, you can derive. That's the purpose, okay. So no need to derive it in the question answering sections, okay. All right, so let me see. Yes. Okay, hope everyone understand. So I'll continue the things. Okay. Okay, let me go back to the notes where we have stopped. We are in our 4 fixed point iterations. So we have finished 2 methods. The third one, it's called as a fixed point iteration method. Okay. So before that, like what I have done for you earlier, I'm gonna show you what is the idea of fixed point. Before studying this one, let's see what it is. Okay. Okay, let me go back to the whiteboard. Step 1. Okay, here. So fixed point method. Oh, just a small, put a small heading fixed point method. So what it is doing is, let's say, for example, my gx is equal to, I have my function fx equal to 0. Okay. I'm having a gx, let's say, x squared minus 2. So in the interval, let's say x belongs to minus 2, 3. Okay. Then, can you find g naught, g, let's say, let's put this g minus 2 and g of 3. Can you find the answers? these three answers. What is t naught? What is t minus 2? What is t minus 3? Just to substitute the x equal to 0, no? Okay. So what I have observing is the same people are answering me. What about the others? So if it is not, I will call your number. You have to answer with others. Okay, I will expect your answer. I will call the registration number or anything. So I want you everyone to be, in the class very attentive. The same people only answering every time for me. Okay, this is simple thing, no? Just to put the x equal to 0. So 0 minus 2 will be minus 2. Yes. If you put minus 2, minus 2 squared will be 4. 4 minus 2 will be 2. Yes, 3. 9 minus 2, 7. Easy task, isn't it? So if so, can you find what is dgx over dx? What is the derivative of g?